So trig identities are basically equations that involve trig functions, right? So that the right side and the left side are the same, right? So for example, take a look at these identities here. Another word for trig identities is like they're just trigonometric facts, okay? All right, so take a look at what we're going to go over first. These are not new. You've known these, but now we're just going to give them a name. We're going to call these reciprocal identities. Since the beginning of the year, you've known that cosecant is 1 over sine, correct? You've known that secant is 1 over cosine, so they're reciprocals of each other. And so, you know, we can go both ways. Sine is 1 over cosecant and so on. So these are the reciprocal identities. All right, right here. And then since the beginning of the year, we've also known tangent is sine over cosine. That's not anything new, is it? Tangent is sine over cosine. We're now going to call them a quotient identity. Like this was a fact. We knew it. Right now we're just giving it a name. It's a quotient identity. You don't have to refer to it by the name. It's still the same from where you're sitting. Tangent is still sine over cosine. So, in other words, if you are given sine of theta, then cosecant is just the reciprocal. Meaning, if sine of theta is 2/3, then cosecant will just be what? What do you guys think? 3 over 2, the reciprocal, yeah. Okay, good. So here's another example. If cosine is 3 over 4, then what's secant?
4 over 3.
Correct. All right? Now, take a look at the next one. You're given secant, and you're given tangent, and you have to find sine of x. So here is what you need to find. So what you have to do is find a way to connect sine of x to what you have, to what you're given. Okay? All right, so for that, let's go up here. Well, okay, I'm given tangent and I'm given secant, but what if you're given secant, what else do you also know? Do you also know the cosine? Yeah, if you're given secant, do you also know the cosine? Because they're reciprocals, right? And I need to find sine. So is there a way that cosine and tangent and sine are related? Any way here that sine and cosine and tangent are related? Yeah.
They're related because all the numbers are all in the same triangle.
Right, but which identity here? Do you see how this relates all of them?
Yeah.
Right? The tangent, the sine, and the cosine. So that's what we're going to use. We're going to say, we're going to use tangent x equals sine over cosine x. Okay, but now, what am I looking for here? What am I eventually solving for? Sine of x. So here, is there any way I can get sine of x alone by getting rid of the cosine?
Yeah.
Multiply both sides by cosine, right? So now I got cosine x, tangent x equals sine x. Okay, cool. But where am I going to get cosine x from? Look at what I'm given. Where do I find cosine x? This is tangent. That's no good. Is that related to cosine right there, the 5 over 4? Right. It's the cosine is just 4 over 5 times. What about tangent? Tangent is 3 over 4.
So the 4's cancel out.
Correct. So these cancel out. That means sine x is 3/5. Okay? And that's that. Okay. So, no, yeah.
I found 3/5 without doing that equation because, like, I just looked at the two numbers and then
Right. So
Can I do that? Or do I
You have to show me some work. Okay? Okay.
I have a question.
And things will get more complicated anyway.
I have a question. I
Yep.
have actually more of a comment. I heard that section 5 is the hardest section. That was
So, okay. So, we've been working with this from the beginning of the year, right? That when you have a triangle inside a unit circle. Okay. We've learned that when you have a right triangle, the horizontal is always the cosine, the vertical is always the sine. Okay? Now, so the horizontal, right, or the x basically is always the cosine, and the vertical is always the sine. Okay? Now, this is also a right triangle. So if we wanted to use the Pythagorean theorem on this, what would this be? Y squared plus x squared equals what? What would the Pythagorean theorem be for this one?
1 squared.
Y squared plus x squared is equal to
1 squared.
1 squared, right? Okay, also though, since this is sine and this is cosine, it would be sine squared plus cosine squared is equal to 1. Yes? So that's the idea from where this Pythagorean identity comes from. So we use the Pythagorean theorem for this, right? And we came up with this. So this, because it came from the Pythagorean theorem, is called the Pythagorean identity. Okay?
Oh, we need to know that.
Okay. We're just going to do this right now. Okay, I'll tell you everything that you need to know for the test later. Okay? All right, so this is called the Pythagorean identity. This is like a VIP in the identities for this section. All right? And it's got friends, right? So there are 3 Pythagorean identities, and here they are. The most well-known is sine squared plus cosine squared equals 1. And then the other 2 basically come from this, right? All of them are used equally frequently depending on where you need one versus the other. So, take a look here. We've got this identity, right? And it says here to solve each of the following for the stated quantity. So solve this identity for sine squared theta. So here's what I'm going to do. I'm just going to rewrite this identity here. Okay? We're going to solve it for sine squared theta. That means it's going to be sine squared theta alone equals to something else. So what am I going to do? How can I get rid of the cosine in order for a sine to be alone on this side? What are we going to do? Subtract cosine squared theta, right? Okay? So this goes away. Garrett, can you write these down? So what do I have left? Sine squared theta is equal to 1 minus cosine squared theta. So basically just showing you that this identity, like, it's not a rigid thing, right? It can be manipulated to look differently, all right?
What does that look like? Oh.
This was the initial identity. I now solved it so it says sine squared theta equals the other stuff. Okay, I rearranged it is what I'm saying.
I understand, but there's no negative cosine squared theta in any of the Pythagorean.
It doesn't, right, that's exactly the point, is you can take one and you can write it in a different form.
Okay.
Okay, so that's what we're going to do here now. We're going to take the same one and now we're going to solve it for cosine squared theta. So what am I going to do here to solve for cosine squared theta?
You subtract sine squared.
You subtract sine squared. So I get cosine squared theta is equal to 1 minus sine squared theta. Okay? And that's pretty much it. I mean, I've broken things down here just so it gets us used to rearranging the identities. Okay. Now, take a look at this one. It says to solve the exact same one, this time for 1 minus sine squared theta. So what I'm going to do, just to give us a little bit more space, I'm just going to rewrite that formula. Okay, so what I need here is 1 minus sine squared theta on its own. I have a 1 here. What can I bring here so I get 1 minus sine squared theta?
Sine squared theta.
Right, so what would I do with the sine squared theta?
You subtract it.
You subtract from both sides. Right, so I get cosine squared theta is equal to 1 minus sine squared theta. Okay, so 1 squared theta equals cosine squared theta.
What's the difference between that and the one so just done?
Not much for now, but later on, like in the next 2 lessons, you're going to see that all of these are going to fit into different places. Okay? All right, this one's important. We're going to solve this for cosine squared theta minus 1. Okay, so let me write it again. Okay? Okay. So, if I need cosine squared theta minus 1 on the same side, can I have sine squared still be on the same side as the cosine?
Negative.
No, I need to bring this over, right?
Indeed.
So what do I have now? Cosine squared theta is equal to 1 minus sine squared theta. Is that what I need?
No.
No, I need cosine squared minus 1. So how about if I subtract the 1 from both sides? Now I get cosine squared theta minus 1 is negative sine squared theta. Okay? So that's how I solved for that one. Okay. So take a look at what we've got here, right? It's a multiple step process. If cosine of theta is equal to 1/3 and tangent is less than 0, we need to find sine of theta. Okay, so this is what we're given here, and we need to find sine of theta. Okay, the first step for these is always use the information on the sign, plus minus sign, to determine the quadrant. So here's what we're going to do. We're going to draw a unit circle. Do you remember this was all students take calculus? Okay.
Yeah.
So we now have on top, at the very first line, if cosine equals 1/3, tangent is less than 0, we have 2 pieces of information. The first piece of information is cosine theta is 1/3. Okay, you see how it says cosine theta is positive 1/3? This tells you cosine theta is positive. So put a plus in all the quadrants where cosine is positive. Where is cosine positive? In the first quadrant and the fourth quadrant. Okay? So here we put a plus where cosine is positive. Okay, next I'm given this. I'm given tangent of theta is less than 0. Less than 0 means tangent is negative. So you want to put a minus sign where tangent is negative. Where is tangent negative? Is tangent negative in the first quadrant?
No.
No. In the second quadrant?
Yes.
Yes. In the third quadrant?
No.
No. Tangent is positive, so it's negative here, right? So the way I think about it is, tangent is positive first and third, it's negative in the other 2.
Why?
Because all students take calculus, all are positive here. T for tangent is positive here. So tangent is positive here.
Why is all?
negative in the other ones?
I'm so lost. Why is all positive?
Because it says when you have all there, all stands for all the functions are positive here.
Oh, okay.
S stands for only sine is positive here. T stands for tangent is positive. C for cosine. Okay, so now when you do this correctly, there's always going to be one quadrant where you're going to have two symbols. That's the quadrant that we're working in. Okay, so working in quadrant 4. So that's the first step, is fixing the quadrant. Yep.
Is it always quadrant 4?
No, but when you do this correctly, there's always going to be one quadrant where two things match up, two symbols match up. Okay, so now, next, find the trig identity that most closely relates what you have and what you need to find. So, I have cosine. I need sine. Okay? Usually, you're going to use a Pythagorean identity for this. So take a look at these. Find one that relates what you need to what you have, sine and cosine. Which one relates sine to cosine here? The first one, right? So we're going to use sine squared theta plus cosine squared theta equals 1. Okay, what do I need to find here?
Sine.
Sine. So can I solve this for sine just like we did earlier?
Yes.
Yep. So sine squared theta is 1 minus cosine squared theta. Okay, so sine squared theta is 1 minus. Okay, what's cosine? What's given to us for cosine?
1/3.
1/3, but this is cosine squared, so I square it. So, sine squared theta is 1 minus 1 over 9. Okay?
Wait, why did you square the 1/3?
Because the formula says sine squared is 1 minus cosine squared.
Oh,
Okay?
oh.
Okay. So, squaring, I get 1 minus 1 over 9. Then, when I
I'm
subtract,
sorry, can you wait just a second? I'm so sorry. I'm so lost.
okay,
Sorry.
so when I subtract, what do I get? 9 minus 9 minus 1 over 9, 8 over 9.
Where'd you get another -9?
Okay? 1 is 9 over 9. Minus 1 over 9 is 8 over 9.
We have to find
I feel like we're simplifying down to the bottom of the earth.
Now I'm going to take a square root of both sides. Okay. Okay, we're going to take a square root of both sides. So sine of theta is equal to, when you take a square root, it's plus or minus root 8 over root 9, right? Whenever you take a square root of both sides, it's always plus or minus. Okay, now, which quadrant did we say we were working in?
The fourth.
We said we're working in the fourth quadrant and we're looking for sine. In the fourth quadrant, sine is negative, right? So here I'm going to take the negative version of this. All right? So I say sine is negative root 8 over root 9. Okay, but negative. Okay, so look, the denominator, root 9, that's just 3. What's root 8? 8 simplifies, right? You guys remember from like way back when?
2/4.
So that's 2 root 2. And so that's what we have for sine.
I forgot which one goes in.
Okay.
The pair that goes
The
in?
pair comes out. It's
That's
like
right.
they're in jail. When you find a pair, you come out. Okay, so now, B. B says, now find tangent. Okay, so let's go back since the beginning of the problem. What do we have? Okay, we now have more things. We have cosine and sine. We need tangent. Okay, so now look. The first round, we used the Pythagorean identities. But now that we have more things, we can actually go into the other stuff as well, right? So we need tangent. We got sine and cosine. Look, we can use this one, right? Because this one relates all three of them. So that's what we're going to use. We're going to use tangent theta equals sine over cosine. So tangent theta equals sine, I just found it, was negative 2 root 2 over 3. Tangent is cosine is 1/3. Okay, these go away. So I got negative 2 root 2. Okay, for this one, we're going to follow the same steps. We're given cotangent. We need to find sine and cosine. Okay, go up here. The first step was draw the unit circle and figure out which quadrant we're working at. So that's what we're going to do. So draw the unit circle. And remember, it's all students take calculus. Okay, now you're given two things. You're given cotangent of theta equals 2. That means cotangent is positive. Okay, cotangent is like tangent. It's positive here and here. Okay, you're given cosine is less than 0. Okay, cosine is negative. Okay, cosine is negative here and here. Right? So do you see, again, there is one quadrant where you've got two things.
I thought it was
In the first problem, it was in quadrant 4. But in each problem, it's going to be a different quadrant.
No, but isn't the first section like all?
This is where all is positive, and this is where cosine is positive. But here we want cosine to be negative.
Cosine is negative.
Right, because look, cosine is positive here, but negative here. These tell you where they're each positive, but they don't tell you where they're each negative. Okay, so that's the first step. Now we know we're in quadrant 3. Okay, next step, find the trig identity that relates what you have to what you need. I have cotangent theta. I need sine or cosine. Okay, those are going to go with, those we're going to need the Pythagorean identities for, right? So let's go here. I have cotangent. I need sine or cosine. Okay, so let's go here. Okay, this is cotangent. It relates to cosecant. But if I find cosecant, is that not the same as sine anyway? It's just a reciprocal?
Yeah.
So I can go ahead and use that one. Okay? So let's go ahead and use that one.
Could you use the other one though?
You can use more than one. Which other one do you think you can use?
Can't you use the one in the middle?
The tangent one you can, and then that'll give you secant, but you still have to flip it around to get cosine. You see that?
Yeah.
Okay, so let's use this one. They are like a puzzle, and there is always more than one way to do it. So use cotangent squared theta plus 1 equals cosecant squared theta. Okay, so we're solving for, okay, fine, cosecant squared, that's good enough. So let's see. I have cotangent is 2. But this recipe calls for cotangent squared, so it's got to be 2 squared plus 1 equals cosecant squared. Okay, what does that give you?
5.
5 cosecant squared theta. Okay, take a square root. And now cosecant is plus or minus root 5. Please don't forget the plus or minus. Okay, I have cosecant, but I really needed sine or cosine. But that's cool, right? Because sine is what? Plus or minus? 1 over root 5. So now we have to decide, is it the plus or the minus? What quadrant are we in? Third. Is sine negative or positive in that quadrant?
Negative.
Negative, so I got to take the negative. Okay, so sine of theta is negative 1 over root 5. Yay. Okay, cool.
Now
But
we have to find cos.
now we have to find cosine. Okay, so make a list again of what you have,
9.
what you need. Okay, so what do I have? I have cotangent, and I have sine. I need cosine. Okay, remember when we were doing the law of cosines and then the law of sines? Whenever we had to use law of cosines, we only used it once, and then after that we could use law of sines to continue. It's kind of the same thing. When you use a Pythagorean identity, to continue, you can really use one of the other ones. So I have sine and cotangent. I need cosine. So what do you think? Anything here that relates sine cotangent to cosine?
The quotient identity, the one above.
Well, what about this one, right? Yes, that one works. This one here. So cotangent is cosine over sine. Where are we? Okay, so let's use okay. What am I solving for?
2 equals
Well, what quantity am I solving for?
your cosine.
Cosine, right? Let's isolate the cosine here. So let's get rid of everything else. Okay?
Oh, you do that first? Oh.
I would, because then it gets kind of complicated with the fractions. Okay.
I don't understand why sine equals theta, or sine theta equals negative 1 over square root of 5.
Did you understand why it was?
Well, I've been copying stuff down as well as, so I didn't really get to pay attention.
Okay, I can go back in a minute. So sine of theta, we're gonna plug things in now. Negative 1 over root 5. And then what's cotangent?
2.
2. And that's like 2 over 1, right? So cosine of theta is negative 2 over root 5. So even and odd identities. Here's how this works. If you have a negative inside the sign, the negative basically comes out. Okay? If you have a negative inside the tangent, it basically comes out to the front. If you've got a negative inside of the cosine engulfs the negative, and so it goes away. And because the bottom ones are just reciprocals, they follow the same rule when it comes to positive or negative, right? So how do we use these? Let's do the first one. You've got cosine of negative pi over 3. Well, because it's a cosine, the negative just gets engulfed. And so this will just be cosine of pi over 3, right? The negative just gets engulfed.
What does that mean?
Now it goes away. Now, we need to find cosine of pi over 3, okay? For that, you got to go to the rescale triangles. Remember, cosine is always the horizontal side. Cosine of 1 over 3 is 1/2. Okay?
Why does it go away?
Now,
I don't get it.
It's the identity. It's the rule. That you just have to know that that's what happens, okay? Now, for the sine, when you've got sine of negative 45, because it's inside the sine, it comes out. So it'll be negative sine of 45 degrees. So when you're going to evaluate this, this is negative. For sine of 45, you got to go to the rescale triangles again. 45 is like the pi over 4. Sine is always the vertical. It's 1 over root 2. So it's, altogether negative 1 over root 2. That purple negative was from the negative from before. All right? Okay. Next, for tangent. What happens with the negative? Go away or come outside?
It goes away.
It comes outside, so this will be negative tangent of 7 pi over 6. So now I have to evaluate this like we did in chapter 4. So this is negative. Now let's see what happens to tangent 7 pi over 6. Okay.
It just goes pi over 6.
So 7 pi over 6 is like 1 and 1 over 6 pi. Yeah? So
Why? You just
mixed numbers. So this is 1 and 1 over 6.
1 over.
Okay? Let me finish this whole thing and then I'll take questions. So we are in this quadrant where tangent is positive. Okay. So now, because it's pi over 6, remember the reference angle? This is like looking for tangent of pi over 6. So we go to pi over 6 on the rescale triangle. Okay? And it's sine over cosine for tangent. So this is going to be 1/2 over root 3 over 2.
1 over root 3.
These go away. So I have a negative from the front, 1 over root 3. Okay. Last one. Hang on. Last one. We have a cosecant. Cosecant is like the sine, the negative comes out. So I have negative cosecant 5 pi over 3. Okay. Again, we're going back to chapter 4. That negative, I'm just going to copy it down. Make sure you don't lose sight of those negatives, right? So 5 pi over 3 is like 1 2/3 pi. So let's see where that is. 1 pi, 2/3 pi, fourth quadrant. I'm looking for cosecant, which is negative in that quadrant because it's like sine. Okay, this is a pi over 3 angle. I go to my pi over 3 triangle. Cosecant is the reciprocal of the sine. This was the sine, the vertical, root 3 over 2. So the cosecant is going to be the reciprocal 2 over root 3. Okay? All of this is from 4.3. And so that we put over here. So altogether, it's 2 over root 3. Okay? Okay, now,